instructor. My name is Yuvegan Rao. My student ID will be DN2000012. So today my friends and I from group 3 are going to be presenting about AC power analysis and three-phase circuits. So without further ado, I'll just introduce my friends first. We have Vinod Shiva, myself, Yuvegan Rao, Magdelene, and also Sambavi. So as you can see on screen, AC power analysis, every electrical device has a power rating that indicates how much power the equipment requires. AC in AC current stands for alternating current, as we all know, which can refer to either voltage or current that alternates in polarity or direction respectively. This does not actually act as a source or supply of power, but rather as a power converter to reduce the exodus voltage of wall circuit power to a much safer level. If it exceeds the power rating, it can cause permanent damage. On the other hand, three-phase systems can be divided into two, which are the single-phase 2-wire system and single-phase 3-wire system. In a single-phase 2-wire system, single source will be connected to a load using 2-wire system, and in a single-phase 3-wire system, two sources will be connected to the 3-wire system. In addition, the sources in this system have equal magnitude and I phase. So as you can see on screen, this is the circuit we have chosen from the textbook, figure 12.58 for problem 12.39.
Hello everyone. Yeah, I'm Magdelene Moses and my matric number is DN2000003 from group 13, section 1. Okay, today I will present about our project which we choose problem 12.39, figure 12.58. Okay, I will show you the calculation that have been done. Okay, here are the circuit. I have been redrawn the circuit and identify the meshes and also assign the current to each mesh using a clockwise direction. Okay, here are the calculation that I'm using mesh method. I've done mesh 1, mesh 2 and mesh 3 and come out with the equation 1, 2 and 3 by applying KVL. Okay, after that, to eliminate I2, I have been multiply the equation number 1 by 2 and the result is I listed out as a question 4. Next, I subtract above question 3 from question 4 to get value as in question 5. And again, I'm multiplying equation 2 by 5 over 4 and listed out the value as a equation 6. Then, I add the value from equation 1 and equation 6 to get the value for equation 7. Next, I'm using metric form, include equation 5 and equation 7 to find I1 and I3. After that, I substitute the values of I2 from equation 6 to get I2. Then I calculate the average power absorbed by the 8 ohm resistor for P1 and 4 ohm resistor to find out the value of P2 and also a 10 ohm resistor to find out the value for P3. Lastly, to find out the total real power absorbed by the load, we have to calculate and combine all the P1 plus P2 plus P3 and will come out the answer with 431.1 watt.
My name is Vinod Shiva and my metric number is DN2034. So I'm representing my group 3 to present about the simulation of our project. So we basically has chosen the circuit from textbook at page 572, that is 12.39, the circuit on it. So I'm doing the simulation part for my group and I basically use the Falstad circuit simulator. So this software is basically we can get it on the online. So basically this is an online software. Okay, so let's go into the circuit simulation. So according to our diagram, we have a three-phase circuit. So I arrange the circuit like this. So then it can be easy to simulate the circuit. So I fix it with 2 voltage terminal source for each part of the three-phase circuit. So here it is, the three-phase circuit, and then the loads I arrange it directly copying from the diagram. So but for this part in the diagram is supposed to be in triangle, but to make it simple and easier, I arrange it in square, but the simulation or the working of the circuit will be the same. So these are the loads. I change each the value according to the diagram. So these are the 10 ohm resistor, 8 ohm resistor, the capacitor 6 at the value of 6, and the resistor 4 ohm and the inductor 3. So the each value of the loads has been copied from the diagram itself. And then for the three-phase circuit, three-phase diagram circuit, I simply put the maximum voltage according to the diagram, and then I change the phase offset, the degree of the each part of the three-phase circuit according to the degree has been given. That is 0 degree. This is negative 120 degree, and this one is 120 degree. So, doctor, as we can see, after I run the simulation, I found out that the value of each load that has been chosen, that is 8 ohm, 10 ohm, and 4 ohm, is very different with the calculated result. I assume that maybe the arrangement of the circuit in the software might be slightly error, or maybe I changed the complex number of in the diagram into a real value. Like it's supposed to be like this capacitor value supposed to be like 6 I changed it to the real value to 6. So I got it from the calculation. So that's all from me, doctor, for the simulation part. Thank you so much.
Hi, my name is Sambavi Thiruvengkatarajoo. I would like to present about the discussion of this project. In our project, we choose the circuit 12.39 based on our textbook page 572. The circuit we choose was related to the topic requirement of the project, that is topic power analysis and three-phase circuit. To complete this project, we split our task among our group members so that we can complete it as soon as possible. The most important task in this project was calculating and simulating the circuit. So as a group of 4, we plan out our task and we manage it to complete it in the given time. Moreover, while doing this project, we also gain a lot of knowledge about the required 2 topics. The circuit contains an unbalanced system when the source voltage differ in phase by angles that are unequal. An unbalanced 3-phase system are solved by direct application of mesh and nodal analysis. Then the circuit is calculated and the average power was found in each resistors using the formula. And the real power was calculated by summing up the total average power in each resistor. The circuit was analyzed and calculated separately in manual and through using software called Falstad. Next, conclusion. In conclusion, we learn what measurements are to be made and how field measurements are converted to actual power values. We can conclude that unbalanced system is due to unbalanced voltage sources or an unbalanced load. The set of unbalanced line currents produce current in the neutral line, which is not zero as in a balanced system. There are delta connected loads and Y connected loads. There are 3-phase 3-wire circuits and 3-phase 4-wire circuits. And of course, there are balanced load and unbalanced loads. To better understand, 3-phase circuit is essentially a combination of 3 separate single-phase circuits which happen to have peaks and valleys by a period of time.
Again, so I am here to share about future recommendations. So our first idea is that to develop ideas on making AC more reliable. Other than that, we need to it's a need for inverters. Critics of AC power comment on the use of inverters to transform electricity from batteries into AC when we used in home power system. They say that this is added expense and can be costly. Apart from this, there are also the waste associated with converted energy that can be between 5% to 15%. Also, most of the appliances designed for AC use are wasteful in terms of consumption. Thirdly, coming into 3-phase systems, we should avoid fault or failure, which leads to power supply shutdown in the whole connected load areas. Last but not least, we should increase the capacity because the 3-phase systems are self-cooled. The system's power will also be reduced simultaneously. So that's it from us. Thank you very much, Doctor.